Hello everybody, welcome back to chapter 3. In this one we're going to learn how to develop with GridDB. So let's go ahead and get started. Alright, so for this first section we're going to go over data modeling. Data modeling is basically going to explain to you the best way to set your tables up depending on your application, how your data will be laid out, basically your schema for your entire application. All right, so to begin with the data modeling, first you would have to understand that since this is a NoSQL database and it's focused on IoT development, it's a little different from just your usual relational database management. So the first thing to know is that in this case, you would want each device or sensor or application to get its own container. So this means that, for example, if you have some sort of project where you have a bunch of different sensors all around a building emitting data, each of those containers will get its own time series or collection container. So with this, they will all typically share the same schema. So typically all the sensors will probably be emitting the same kind of data, just from different sensors scattered around different locations. And then the container key itself would be the unique ID. So basically here's a graphic. So you could have, for example, one accounts container, and then one of the columns in there is an array, and that just contains all the unique sensor IDs. And each sensor ID corresponds to a different time series. In this case, it's a time series container. You can see the timestamp is the row key. So each sensor ID, each container name will have a unique ID. So it'll be reading underscore and whatever that sensor ID is. And then, yeah, all the data will be the same across all the sensors. This way, it really helps to organize all the different sensors, and also helps for scalability, so you could easily add more sensors as they become available, or if you need to replace one because it breaks, or any other of the myriad of reasons. All right, so now to expand upon the data model versus a relational database model, let's look at the same kind of scenario and compare them one-to-one. So on the left, we have the relational database model, and the right is the GridDB key container data model. So you can see here on the left, all the sensors on the relational database side are put into one table. So we did it this way because it's actually the most efficient way when you're using relational database to put everything into one table. But you can imagine now, let's say that this project scales up and we end up having several tens of thousands of sensors for the entire project. So you can imagine how quickly it would become very slow and cumbersome to use the relational database side, trying to read data from this table named sensor reading with tens and thousands of sensors. It would be unwieldy. And if you compare that to the right side, the key container side, where, as we explained before, each sensor would get its own container. So you can see in the bottom right of this graphic, there would be an account record container, which is a collection container, where the row key could be anything. And that has an array of all the sensor IDs that are relevant for this account. And then each sensor ID has a unique key, and the value of that key would be a container, and that container is the sensor data for only that sensor. So you can imagine if we scale up to even hundreds of thousands, it doesn't really change the performance all that much, because each sensor has a unique, basically its own table. So basically this data model will allow developers an easy and efficient way to model data, time series or not actually. So if there are many individual inputs, this is the best way to handle that. So that's why IoT type scenarios really flourish with GridDB's key container data model.